In order to solve equations that contain radicals, we're going to have to use this tool called the power rule. So if both sides of the equation are raised to the same power, all solutions of the original equations are among the solutions of the new equation. That means sometimes we'll find a solution by using this rule that is not actually a solution to the original problem because of what happens when it's used that way. So solutions to the equation may or may not be proper solutions of the original equation. Therefore, all answers must be checked in the original equation. And if this solution doesn't work, then we're just going to disregard it as an extraneous solution, which means it's not a solution that we need to the original equation. So the important thing about the power rule is you're raising the entire side. So for example A here, we want to solve this equation. There's a radical on one side of the equation. And so in order to get the radicand out of this side, I need to raise to the power of the index, which is 2. So I need to raise the other side to the same power to stay equivalent here. So that will cancel out the radical on the left side, leaving just the radicand, 3x minus 2. On the right side, 4 squared is 16. And now this is a linear equation, so we're going to solve this like chapter 2, which is I'm going to opposite this number term so that I have just the variable term on the left side. Same thing on the right side of the equal sign. So 3x equals 18 altogether. And then I need the division tool to get x by itself. So just 1x is 18 divided by 3, which is 6. So I think this is my solution. I'm going to make sure. So if I put that into the original equation to check, then x is 6. Everything else stays the same. So multiplication first, 18 minus 2. And then subtraction, that's 16. Square root of 16 is 4, absolutely. So that means this is the proper solution to this equation. Our steps in general then are going to be a little bit more complicated because the equations may be a little bit more complicated. So to solve a radical equation, your first step is going to be to isolate one radical on one side of the equation. It says one radical because you may have more than one radical in your equation. So one radical is the only thing on that side of the equal sign. Must be done first. If you don't do that first, nothing else is going to make any sense. It's not going to be correct. So once you have isolated one radical on one side, raise both entire sides, that's the key, to the power of the index. And simplify. If your equation still contains a radical, which it may if there was more than one, then go back to step 1. Isolate that radical. Well, then use the power rule again. Otherwise, continue solving the equation, whether it's linear or quadratic. We'll do different steps there. And then don't forget to check all of your solutions in the original equation to make sure that they're actually true for that equation. That's the whole point. So example B, I have my radical right here on the left side, and then there's more stuff here. I don't want more stuff. I need that radical to be the only thing on that side. So I'm going to opposite the whole term that's on this side. So plus 2x to both sides of the equation. Then on the left, I have the radical equals the right. 0 plus 2x is 2x. Now I'm going to use the power rule. So raise the entire sides to the power of the index, which is 2. So that leaves just the radicand on the left side. On the right side, I've got a product to a power. So 2 squared times x squared is 4x squared. And now I can see that this is a quadratic equation because it's degree 2. So I want everything to be on that same side. I'm going to opposite both of these terms here. Minus 9x plus 2. So that I have just 0 on the left side. And then none of these are like terms on the right, so they all stay separate. And then I have a trinomial, so I need to see if I can factor this trinomial. I'm looking for factors of the first and last term that add up to the middle term. So factors of 2 can only be 2 times 1. But 4 could be 2 times 2. I don't think that's going to work. 4 times 1. So let's see. Multiply across 8x and 1x. They have the same sign. They're both negative. Let's see. Yep, that works. So we have a 4x minus 1 factor and an x minus 2 factor. So now we use the zero product property. Set each of these factors equal to 0. And we'll solve those resulting equations. So for the first, that's going to be a 1/4. And for the second, just add 2, so get a positive 2. All right, so I think I have solutions of 1/4 and 2. Let's see if there's any reason why those would not be true. So let's check those. If I use the 1/4, then 9 times 1/4 is 9/4. And let's just do 2 times 1/4 is 2/4, which is a half. So I need this 2 to be in fourths as well. How many fourths is 2? That's going to be 8/4. So let me just change that to 8/4. So that I can take the difference here, and that difference is 1/4. And the square root of 1/4 is 1/2. So that does add to be 0. So 1/4 is good. Let's check 2. Square root of 9 times 2, so that's 18. 2 times 2 is 4. And that difference here is 16, where the square root is 4, so that definitely works too. So we can confidently say that these are both solutions to this equation. They're proper solutions, they work. Another problem here, I've got my radical on the left side, and there's another term over here, so I need to opposite that term, so the radical is the only term on that side. So cubed root of x minus 5 on the left side. 1 minus 2 on the right is -1. And that's okay. I'm going to raise entire side to the power of the index. So that will cancel out the radical on the left side, leaving just the radicand, because the nth root of a to the n is a. And on the right side, -1 to the third power, that's going to be -1 still. So now this leaves me with a linear equation. It's degree 1, so just going to solve for x by oppositing that number term from both sides, and -1 plus 5 is 4. So I think 4 is my solution. Let me go ahead and check here. So if I put 4 in for x, everything else stays the same. Is that true? 4 minus 5 is -1. The cubed root of -1 is -1. So yeah, that works out. 4 is my solution to this equation. Example B here, I've got my radical on the left side, and that's all that's there. So I'm going to go ahead and use the power rule. Make sure you raise the entire side. This is the mistake people often make, is they try to raise those terms separately, but you must raise it as an entire side. You must. Otherwise it doesn't work. It's not equivalent. It doesn't make sense. So the index is 2. I'm going to square both sides. That leaves just the radicand on the left side. On the right side, I have to multiply that z plus 3 times another z plus 3, so that's going to be z squared plus 3z plus 3z plus 9. So z squared plus 6z plus 9. Now I can see that this is a quadratic equation. So I need to get 0 on one side. I'm just going to opposite these terms here. So -9 from both sides and minus z. Then I'll have 0 on the left side. z squared plus 5z, and then that cancels to 0, so just that. Then I need to use the zero product property, so I have to completely factor this side. It looks like those two share a factor of z, so let's divide that to see what remains. Z plus 5, so that's already factored. Let's set each of these factors containing a variable equal to 0 by the zero product property. So we've got 0 and a negative 5. We've got two solutions here. Let's see if they work. So let me go ahead and check these. Let's check 0 first. So square root of 9 plus 0 equals 0 plus 3. Yeah, that's true. 3 equals 3. Now let's check negative 5. So the square root of 9 plus negative 5, so that's 4, equals negative 5 plus 3, which is negative 2. Is that true? 2 equals negative 2? Nope. That's not true. And so that's the problem that you'll come across when finding these solutions, is that sometimes you'll have a square root equal to a negative number like that. Whenever that occurs, that's going to show you that that's not a proper solution to the equation. So z equals 0, that's the only solution that works for this equation. Now, example C here, you can see that we have two radicals. So I need to get rid of one of them. I need to move by oppositing one of these. And it doesn't matter which one, but I'm going to opposite the smaller one. So add a negative root 3x to both sides of the equation. Then you'll have square root of 3x plus 1 on the left and 2 minus square root of 3x on the right. Now I can raise entire sides to the power of the index, which is 2. And so that leaves me just the radicand on the left side of the equation. On the right side, I'm going to have to multiply those. So 2 minus root 3x times another 2 minus root 3x. So 2 times 2 is 4. Then I have a minus root 3x and another minus 2 root 3x. So there's minus 4 of those altogether. And then if I multiply, well, negatives will be positive, but if I multiply root 3x times root 3x, I can put those into the same radical, right? And since there's two factors of each, then that has a perfect root of 3x. So 4 minus 4 root 3x plus 3x. And this is the situation where you see we have a radical in the equation still, which means I need to isolate that radical now. Again, so back to step 1. So that means let's opposite the other terms from both sides of the equation. So minus 4 and minus 3x. Then that leaves just the minus 4 root 3x on the right. On the left, that leaves 1 minus 4, which is negative 3. So I still am not completely isolated. There's a minus 4 being multiplied by the radicals, so I need to divide negative 4 from both sides. Then I'll have just the radical on the right side here. And they're the same sign, so that'll be a positive 3/4 on the left. Now I can use the power rule, raise both sides to the power of the index, which is 2 here. So 3 squared over 4 squared is 9/16. And that leaves just the radicand on the right when I square the square root. So I'm almost there. Just need to multiply 1/3 or divide 3 from both sides of the equation. That'll get just x on the right. And on the left side, multiply numerators, multiply denominators. Since 9 is 3 times 3, that means I could divide a factor of 3 here, and that's it. So in the numerator, 1 times 3, and the denominator, 16. So I think that the solution should be 3/16. But again, I must check that, because otherwise, I don't know if that is going to make this equation true or not. So let's check that here. The square root of 3 times 3/16 plus 1 plus the square root of 3 times 3/16 should equal 2. So 3 times 3/16 is 9/16. So 9/16 plus 1, which I need that to be in sixteenths as well, plus 9/16 should equal 2. Okay, so if we add these together, that's 25/16 for the first radical, plus the square root of 9/16 equals 2. And so the square root of 25/16 is 5/4. Square root of 9/16 is 3/4. And that should equal 2, does it? Add the numerators, 8/4 equals 2. Yes, it does. So that means we do have a proper solution here. This is the solution to this equation.